All right, guys, we are doing lesson 5.4. I should be back by the end of this block, but just to get you guys started, you should get a sub. I should have a sub to give you your handout for today, which includes the classwork and the homework. So we're going to break this up into two videos, so you can watch the two videos while I'm gone. Hopefully, I'm back by the time that's over. If not, you can start the homework. So what exactly is a piecewise function, right? So I think of a piecewise function like this, right? It's a function that follows its own set of rules. It's basically just, it's made up of all types of functions, right? So it could be part line, it could be part quadratic, it could be part exponential, it could be part absolute value, it could be part of a lot of different things. We'll probably just mostly stick with lines and maybe some quadratics, maybe some radicals and things like that. But it is just going to be separate parts of those graphs all combined into one whole graph, right? And so this is what it looks like. You see this weird notation. This is what's telling you that it's a piecewise. It's saying that the f of x, or the y value, is equal to, right, 2x minus 1 if the x values are less than or equal to 2. And then otherwise, it's negative x plus 5 if the x values are bigger than 2. So it's made up of two different lines, and it's just that it only works for x values for like each one. And so the domain, right? So, the domain is, you could get it by graphing it. Well, actually, why don't we graph it first and then we'll get the domain. But the domain is going to be everything because you're less than 2, you're equal to 2, and you're greater than 2. So that's just going to be negative infinity to infinity. But I'm just going to show that on the graph once we finish it as well. So we have, right, negative infinity to infinity for the domain. And then when we think about the graph of it, basically, I'm just going to teach you guys just to graph and erase. It's a really simple method to graph piecewise functions. So what we're going to do is just graph 2x minus 1, right? So that's a y-intercept of negative 1, and then it's a slope of 2. So I'm going to go up 2 over 1, up 2 over 1, up 2 over 1, up 2 over 1, or you can go down 2, left 1, down 2, left 1. But basically what we're doing here is just, we are connecting these dots that we just made, and we're going to make a line out of all of this. So that is my graph of 2x minus 1. And then what I'm going to do is actually look at the part that comes after the comma. So this is 2x minus 1, but I only need the graph for x values that are less than or equal to 2. So what you guys are going to do is you're going to turn that pencil around till you get to the eraser, and you are going to erase everything that's not less than or equal to 2. So an x value of 2 is like right there, and that's where my graph is, right there at 2. So I only want less than or equal to 2. I only want these parts here that are less than or equal to 2. I am going to erase everything that is bigger than an x value of 2. So that's basically right through there, right? And so now I didn't draw it great when I drew it, but you kind of get the idea of what it is. So this is the graph, right? And this is it from less than or equal to 2. And since it could equal 2, you just want to make sure that you close it up with like a closed circle. It just shows that it's actually included in there. So at 2 comma, 3, I have a closed circle there because it could equal 2. Then the next one, you just do the same thing. So I'll do it in different colors just to show it, but it's all one graph. So this is negative x plus 5. So that's this y-intercept of 5, 4, 5, which is right there. And then the slope is negative 1. So I'm just going to go down 1, over 1, down 1, over 1, down 1, over 1, down 1, over 1. Or you can go up 1, left 1, up 1, left 1. That's basically a slope of negative 1 with a y-intercept of 5. So I'm going to go ahead and connect those points. And I will get a graph that looks like that, more or less. But again, I need to turn my pencil on. I only want x values that are greater than 2. So again, this is an x value of 2 right here. I only want the values that are greater than 2 on the x-axis. So I'm going to keep all those, and I'm going to erase all of that over there because all of that over here is less than 2, and I only want greater than 2. And so, this is being a little bit slow. Did too much. That's okay. But so like that's where it was 2. I think it was like right there where this one was. But the whole thing, I mean, you could think of the whole thing as one function, so I can trace over the whole thing in one color. It's all one thing. And so that's my graph. Now, normally at 2, because this one's just greater than 2, I'd put an open circle there. But if it lands on the same spot as where this one ended, you can just keep it closed because 2 is actually included. So I don't want to put an open circle there. If this one right here was like up here, I would have done it like this, and then I would have put an open circle at the end. But since it ended where this one ended, or this one started where this one ended, you can keep it closed. It's included. So that's kind of what the graph looks like. And so that's what our final piecewise function looks like. Kind of looks like an absolute value. It's not quite, but it kind of looks like that. So then the range, you're just going to go back to your unit 4 stuff, right? We're saying range is from low to high. It's all right, well, it goes down to infinity, so it's negative infinity. And it goes up to a y value of 3. And it hits that point, so we're going to put a bracket on it. And just to confirm my domain, it goes left forever, it goes right forever, there's no gap, so it's negative infinity to infinity. Now, this one asks if it's continuous. The answer is yes. It's very rare when it's continuous, but basically if you can trace over the whole graph without picking up your pencil, that is continuous. There's no holes in it, there's no discontinuities, there's no place where it jumps from this one to this one. It's all one function connected, so it's continuous. We'd say yes. And then finally, if I said what is like f of 6, you can go to 6, 1, 2, 3, 4, 5, 6, and you could see that the graph would be at -1. Or, since 6 is a number that is greater than 2, you could just plug in 6 for x. So -6 plus 5 is -1. Notice how I would never plug in 6 into this one because 6 is not less than 2 or equal to 2. It doesn't fit with that one, so I wouldn't even look at it. I only get one answer for f of 6, and that is -1. And then we have a second example here, right? So this is my second example. You guys can pause the video and try it on your own. Then you can resume the video once you are done. All right, so for this example, we're going to graph y equals x, which is just a slope of 1 and a y-intercept of 0, so like 1x plus 0. So y-intercept's right there. Slope of 1 is just going to be this way. And so I'm just going to get a graph. I'm just going to do it like this. My graph is going to be, it's going to basically be this. Right there. Slope of 1, y-intercept of 0. And I only need, right, if I look at this, I only need x values that are less than 0. So this is where 0 is for an x. I don't need any of this stuff over here because these x values are greater than 0. So I would normally erase it. What I'm going to do instead of erasing it is just pull it back and say, all right, well, that's where my graph is. And I'm going to throw arrows on this to the left forever. And I'm going to put an open circle here at 0. That's open to show that it's not equal to 0. It's just less than 0, so I do an open circle. But it's not like I stop at -1. I go right up to 0, open circle, and that satisfies this condition. This one's a little trickier. This is x squared minus 1 if x values are less than or greater than or equal to 0, I should say. So again, you can graph the whole thing and then erase it. I'll graph it in green. But basically, if you want to make like a table, you can certainly do that as well. If you don't know what this shape looks like, it is a parabola because it's squared. It is down 1 because it's -1. But if you want to just like plug in numbers, like I could plug in 0, and 0 squared minus 1 is -1, right? I could plug in 1, and I could say, well, 1 squared is 1, and 1 minus 1 is 0. So I got 1, 0. I can plug in 2, right? 2 squared is 4, and 4 minus 1 is 3, so I get 2, 3. And at this point, if I know that it's a parabola shape, I could reflect these points over here, and I will get my parabola shape, more or less. Not the best graph that I've ever done, but that's okay. And so that's my shape. But again, I would then turn my pencil around and say, all right, well, I only need x values that are greater than or equal to 0. So that's where 0 is for at x values. So I'm going to erase anything that's not bigger than 0. So I'm going to erase the left side of it. And this is just really slow. Oh, there we go. And then I have this graph, and this should be a closed circle there at the bottom because it does include 0. So I would just want to make sure that, You're telling the teacher, all right, this is definitely closed. It should be closed. So this one's open, this one's closed. This is not continuous because you can see I stop here and then I jump from there to there. So this would be something that is what we call discontinuous because you cannot trace over the whole thing unless you pick up your pencil to go from here to here. And so that's the end of the first video. We'll do one more video for like working backwards.